The craft was unberthed from Harmony at about 5:05 a.m. Central Time, and then released from the arm a little over an hour and a half later at 6:31 a.m. Central Time, while the station was flying just about 262 miles over the southern Atlantic, just to the east of Argentina. Shortly after that release, the thrusters on board the Cygnus fired to enable the craft to depart the vicinity of the International Space Station, where it will then reach a safe distance and then be commanded by orbital flight controllers to do a deorbit engine firing tomorrow at around 12:41 p.m. Central Time. This will then send the craft through its destructive reentry through the Earth's atmosphere. The craft, which docked back on September 29th, delivered about 1,300 pounds of supplies to the International Space Station crew. So aside from that Cygnus activity, quite a bit of experiment work taking place on board the International Space Station today, starting off with NASA astronaut Mike Hopkins, who earlier this morning was assisting in all those Cygnus operations, checking out the vestibule pressure between the craft and Node 2, or Harmony, as that was installed and activated earlier on last night. Aside from that, Mike Hopkins gathering up some of the tools for the station's EMUs, or the extravehicular mobility units used by U.S. and international partner astronauts out of U.S.-based spacewalks. And also working today with the capillary flow experiment. You can see a live view of that here. The capillary flow fluid physics experiment, quite a few iterations of this on board the International Space Station, ongoing investigation into various fluid delivery systems that are used in microgravity, so we will be able to check in on that progress throughout the hour today. Moving on, European astronaut Luca Parmitano, first thing this morning was busy setting up the EarthCam, the Earth knowledge acquired by middle school students camera. It's a camera used by middle school students around the world to request images of specific locations on Earth. They're completing a mission this week, and you can check out that website that we just flashed up on the screen if you want to learn more about it and get involved. Again, that website, www.earthcam.ucsd.edu. That mission taking place this week, starting today, October 22nd, and going through the end of the week, October 25th. Aside from that, Parmitano uninstalling that Cygnus craft and at the controls of the space station robotic arm alongside with Karen Nyberg today. Parmitano and Nyberg were responsible for installing the craft once it arrived to the station and completing their mission with it today, saying farewell one last time. Parmitano also getting into some experiment work himself, setting up the binary colloidal alloy test, the one that they'll be working on this week, studying nanoscale particles dispersed in liquid. These fairly complex particles commonly found in a lot of commercial commodities down here on Earth. Just a few to be named: paint, electric polishing compounds, and also various food products. Moving on, NASA astronaut Karen Nyberg was responsible for a lot of the setup work, getting ready to detach that Cygnus vehicle, configuring both the Destiny Laboratory and the Cupolas robotic workstations, where they control the Canadarm2, the space station robotic arm, for that deberthing and release of the Cygnus craft. She was also in charge of setting up the hardware command panel for the Cygnus vehicle, enabling the crew to send any commands necessary to the Cygnus vehicle during its deberthing operations. Who's also demating the common berthing mechanism, attaching the craft to the International Space Station, and operating that station robotic arm alongside Parmitano. And one of her other major tasks for the day, working with the resist tubule experiment, familiarizing herself with the operations that will be required for that. It takes place inside of the Japanese experiment module and is a Japanese sponsored experiment on board the station, looking to investigate the mechanisms of gravity resistance in plant growth. Over on the Russian side of the International Space Station, Expedition 37 Commander Fyodor Yurchikhin doing a lot of maintenance work on Russian air and revitalization systems. He's in the Zvezda service module, doing some ventilation system preventative maintenance, some routine work on the systems there, before moving over into the Zarya module. cleaning out a number of the detachable ventilation screens. His Russian colleague Oleg Kotov is gathering up some EVA equipment and tools for an upcoming spacewalk that he'll have on November 9th with the other Russian cosmonaut Sergei Ryazanskiy. Aside from that, he's taking a few readings from the Russian Matryoshka experiment, which an ongoing investigation into radiation monitoring for these astronauts. Also participating in the Russian Moto Card experiment, study of nature of locomotion disturbances for these astronauts in long-term space flights. He'll be on one of the treadmill systems on board the station for that. And the final crew member on board, Sergei Ryazanskiy, doing a lot of that spacewalk preparation alongside Oleg Kotov, also doing some routine crew handover activities and assisting Kotov in his experiment work throughout the day. So as mentioned, the major activity this morning was the departure of that Orbital Sciences Cygnus craft, the second commercial cargo vehicle to successfully resupply the International Space Station. Completed all of its milestones on its flight towards the orbital outpost back in September, following a launch on September 18th from NASA's Wallops Flight Facility in Virginia. This was the final step in Orbital Sciences' completion of the COTS contract, the Commercial Orbital Transportation Services. The Cygnus, which docked back on September 29th, brought up about 1,300 pounds of cargo to the crew. Just a small contingent size of what the Cygnus craft will normally carry during its regularly scheduled resupply flights. Brought up a number of different experiments, including those devised and built by students, along with some food and clothing for these Expedition 37 astronauts. As you can see, the Cygnus was slowly backed away from its berthing point on the Earth-facing side of Harmony, or Node 2. It's done earlier this morning with flight engineers Luca Parmitano and NASA's Karen Nyberg at the robotic workstation controls for that Space Station robotic arm. It was unberthed at 5:05 a.m. Central Time, backed away slowly. Following that, the crew then eventually set up for the eventual release of the vehicle. Parmitano and Nyberg responsible for installing the craft and capturing it once it made its way to the station back in September, just a few weeks ago, just about 3 weeks ago actually. Completing their mission with the vehicle today, as they were responsible for the end game, unberthing it from the International Space Station, the craft loaded with any trash and disposable items from the crew. Following that unberthing, it was eventually released while the station was flying just over the southern Atlantic Ocean. That release coming at 6:31 a.m. Central Time. Craft slowly backed away for about 2 minutes before the thrusters on board the craft fired at 6:33 a.m. Central Time, this enabling the craft to formally depart the International Space Station, eventually setting it up at a safe distance where orbital flight controllers will eventually command a number of deorbit burns and then a final deorbit burn tomorrow afternoon at about 12:41 p.m. Central Time. Cygnus craft, like many of the other unmanned robotic cargo vehicles currently resupplying the International Space Station, disposable vehicle will not survive the re-entry through the Earth's atmosphere. So following that final deorbit burn, it'll put the resupply aircraft or spacecraft into a final descent through the Earth's atmosphere, burning up upon re-entry. That destructive re-entry taking care of all of the trash items packed on board. But again, all of those operations being done flawlessly earlier this morning. The Cygnus vehicle in the final stages of its first visit to the International Space Station. The vehicle will then come online as an official resupply craft to the expedition crews on board the orbiting complex. Orbital Sciences joining SpaceX as the two commercial resuppliers to NASA and the international crews on board. You can see the views of Cygnus following that separation burn thruster fire, departing from the International Space Station for the last time. Welcome back inside the International Space Station Flight Control Room. That again, some video from earlier this morning, following the successful unberthing and release of the Orbital Sciences Cygnus cargo craft. The major times for you one more time. Unberthed from the Harmony module at 5:05 a.m. Central Time. Released from that Canadarm2 at 6:31 a.m. Central Time. And then the separation thruster burn firing happening at 6:33 a.m. Central Time. Then the one final deorbit engine firing will take place tomorrow afternoon at 12:41 p.m. Central, sending the cargo craft through its final descent through the Earth's atmosphere. And right here we're getting some live downlink from one of the science experiments taking place on board the International Space Station. This one known as the capillary flow experiment. There's a full suite of experiments that fall under this name. All fluid physics investigations looking at the phenomenon known as capillary flow, which is one of the major mechanisms for fluid transfer and microgravity here on Earth. Gravity playing a huge role in a lot of different fluid transfer systems, as just naturally brings everything down towards the Earth. In microgravity, however, you don't have that benefit or detraction, depending on how you see it, and fluid transfer systems have to be designed completely different. Some of the important systems that this will play a role in future spacecraft, not only just fuel transfer, but also just general water transfer for crew and experiment work. The one taking place today is known as the interior corner flow experiment, which you can see that small corner mechanism in the very center of the experiment there in the live downlink video. Inside of tanks in microgravity, designers will install these interior corners that are then used so that the fuel will always flow to the outlet of the tank in the absence of gravity, again all through the phenomenon of capillary flow. The actual math and equations used to design these systems are fairly well known, but to date have not been solved on a very deep analytical level just because of the lack of experimental data. So taking advantage of that microgravity laboratory on board the International Space Station with this. All of these different capillary flow experiments, again, very important for the design of future fluid management systems in microgravity. Among those fuel systems for spacecraft, and also cryogenic propellant and various liquid storage systems. Also some of the thermal control systems on board, including water recycling, and then various materials processing for experiments which utilize any various hardware using samples in liquid states. So we'll lose our video communication with the International Space Station for a few minutes while we wait for the communication satellites to hand over. But again, we were just watching along with that capillary flow experiment, having some big implications in NASA plans down the road, as our future exploration missions will assume the use of very large liquid propellant masses, potentially larger than ever flown before. So in those microgravity conditions, capillary flow can be used to control not only the fluid orientation, but also the fluid speeds, so that such large mission critical systems will be able to perform on a predictable and manageable level. So while we stand by for a few minutes now until we get some more video downlink of some of the experiments taking place on board the International Space Station, why don't we take a quick look at all of the work that these crews will be doing over Expedition 37 happening right now, and Expedition 38 continuing months into the future. Some of the exciting experiment work taking place on board the International Space Station.
The main focus for the crew on board the International Space Station this fall is on the station's top priority: groundbreaking scientific research that can't be done anywhere else. Science that helps the people of Earth today and advances the technology needed to support space exploration beyond Earth tomorrow. This crew brings a range of experience to the task, starting with a commander who is finishing up his third long-duration spaceflight with special attention to experiments that could change lives on the ground.
We're working with experience for AIDS, for hepatitis, and for cancer. And if we help humans for one of these directions, I hope we're done with everything, with each dollar, with each ruble on space station program.
Two of the flight engineers, now more than 100 days into their first long mission, are working to find out how the environment of low Earth orbit impacts human bodies.
Probably one of the most important things, at least from the crew member's perspective, is crew health. And so we need to look at all of the things that radiation and lack of gravity do to us and make sure that we can mitigate all the negative effects as much as possible.
Some of that research into ways to protect people from the effects of spaceflight is paying off for people on Earth. For instance, the use of a portable ultrasound machine to map changes to the spine over the course of a spaceflight has applications for using a similar machine in other remote locations.
And developing protocols and softwares to improve the imaging on these machines could mean that soon after we complete our experiments, the technology that we import on the ground could help people all over the world to have access to better diagnosis on their spine.
A once and future space station commander, who is also a medical doctor, has 2 long-duration flights to his credit already, and so he has some insight into areas that need special attention, such as the impact to the vision of some crew members.
The intracranial pressure changes are very serious problems that we need to address. Intraocular pressure changes. So we need to develop some procedures, measures, how we can protect crewmates from that. So this helps not only crewmates, but people on Earth as well.
This crew includes a biochemist whose research has focused on how space travelers lose bone and muscle mass and suffer impacts to the respiratory and other systems of the body over time.
We will start a new experiment to improve the countermeasures system. It's more of a physical exercise experiment. And we also pay a lot of attention to the vestibular experiments as well.
And the crew includes an aerospace engineer who brings fresh eyes to the science of the station on his first trip to orbit.
We have this bone loss, we have the muscle mass loss, we get taller, so all of those effects, we want to try and understand really what's happening and how can we mitigate some of those effects if they're negative. And so yeah, just being there, we are an experiment in work.
In the areas of human life sciences, as well as physics and physical sciences and technology development, plus Earth observation and education, the station's partner nations are pushing the limits of science as they get smarter about what will be needed to support future explorers on missions away from Earth that will last for years. On this flight, the crew will experience something that hasn't happened in years. They'll be part of a 9-person crew on orbit. That happens in early November, when another Soyuz spacecraft arrives. Soyuz Commander Michael Turin, NASA's Rick Mastracchio, and Japan's Koichi Wakata start their tour of duty by delivering an Olympic torch, part of the torch relay to the site of the Winter Olympics in Sochi, Russia, in February of 2014.
During this short period of time of direct handover that will last for 4 days, Oleg Kotov and I will perform an EVA, one of the tasks of which is to take the Olympic torch to space. We will take a picture with it, with the space station in the background, with the Earth in the background, and we will try to make sure that we see Russia and maybe Sochi, where the Olympic Games will take place.
They'll also retrieve a space exposure experiment and perform maintenance on other payloads on the exterior of the Russian segment of the station before bringing the torch back inside. 2 days later, Yurchikhin, Parmitano, and Nyberg depart the station with the Olympic torch in hand. Their departure marks the start of Expedition 38, and Kotov's second tour of duty as station commander. He and Rosansky plan to do at least one more spacewalk in December to install 2 cameras outside the Zvezda module for an optical telescope system, exchange some experiment hardware, and remove and jettison 2 communications antennae from the Poisk module. After that, Expedition 38 figures to be the center of a busy space traffic pattern. The first operational flight of the American commercial cargo ship Cygnus is targeted to arrive at the station in mid-December and stay for a month. Shortly after it departs, the next Dragon cargo craft is due to take the docking port on the Harmony module for a month, and while the crew works on its shipment of supplies, they'll also receive another Russian Progress freighter. Kotov and his Soyuz crewmates leave the station in mid-March to come home to Earth, after nearly 6 full months in space pursuing the advancement of scientific knowledge, learning how to take care of human explorers in space, and learning so much more than that.
We're learning about the world in which we live. We're learning about the machines that it takes to get us there and how those systems operate and how often they need to be repaired and what works and what hasn't worked. And so all of those are such a critical part of taking that next step and going beyond low Earth orbit and continuing human exploration.
And welcome back inside the International Space Station Flight Control Room. That again, a look at all of the groundbreaking science taking place over Expeditions 37 and 38. Expedition 37 happening right now as we speak on board the International Space Station. Expedition 38 will begin in just a little over 2 weeks from now. 3 of the crew members that will be flying up to take place in Expedition 38. Russian Mikhail Turin, NASA astronaut Rick Mastracchio, and Japanese astronaut Koichi Wakata. Veteran crew, all with at least 3 space flights each. Rick and Koichi will be making their 4th space flight. Mikhail will be making his 3rd space flight to the International Space Station. As mentioned, they're just about 2 weeks, a little over 2 weeks away from launch. And then earlier today, over at the Gagarin Cosmonaut Training Center in Star City, Russia, the 3-man crew held their traditional news conference. There you can see them holding a replica of the Olympic torch that they'll be carrying up on their Soyuz TMA-11M craft to the International Space Station. The torch will be brought out on a spacewalk by Russian cosmonauts Oleg Kotov and Sergei Rosansky on November 9th. In addition to that news conference, the crew completing a number of other traditional tasks, including laying flowers at the statue of Yuri Gagarin. They're scheduled to fly down to their launch site at the Baikonur Cosmodrome in Kazakhstan this upcoming Saturday. They'll then complete their final pre-launch training. Again, all focused on that liftoff, currently scheduled for November 7th. Kazakh time. As mentioned, a very veteran crew, all with multiple space flights on their resume already. Among the crew, Koichi Wakata from the Japanese Aerospace Exploration Agency will become the commander of Expedition 39. He'll be the first Japanese commander of the International Space Station.
They're all here, so like, do some exercise.
Here, NASA astronaut Rick Mastracchio, veteran of 3 shuttle missions, STS-106, 118, and 131. And this will be his 4th space flight and his first long-duration mission on board the International Space Station.
Тогда будет поменяться, правильно, Максим?
И сказал, что все, что мы помним о нем, рассказывали, это действительно правда. Насколько был интересен человек для многих людей.
People were smaller back then. Yep. This is a good new tradition over here. This is like summer in Connecticut, where I grew up. It's like advanced. Like in Lightroom.
МКС СУПО СГ-1.
Station Moscow, Space Ground 1.
Again, here you see the upcoming launch crew and their backup crew laying flowers at the statue of Yuri Gagarin, the first man into space.
Не, лучше сними. Тебе холодно?
Все, сейчас снимаем.
So the crew now a little over 2 weeks away from that launch, scheduled right now for November 6th Central Time, November 7th Kazakh Time. We'll be bringing you live coverage of that launch here on NASA TV. It's currently targeted to lift off at 10:14 p.m. Central Time, 11:14 p.m. Eastern Time. And that'll be the Soyuz TMA-11M craft carrying 3 new crew members, Mikhail Tyurin, Rick Mastracchio, and Koichi Wakata, to the International Space Station. A fairly unorthodox traffic pattern for the station this upcoming month. Once they launch and dock, there will be 9 crew members on board the station. Normally, between your crew handovers, you'll have a short period of a few weeks with only 3 crew on board. However, with the addition of the Olympic torch being flown, the schedule got moved around a little bit, so we'll have 9 astronauts and cosmonauts on board the International Space Station for a few days. Following that launch, they'll dock, hatch opening just a few hours following that launch. The 3 crew will come on board, and we'll have a few days of that full extended 9-man crew. Just about 3 days later on Sunday, though, the three of the astronauts on board right now, Fyodor Yurchikhin, Luca Parmitano, and Karen Nyberg, will return. They'll complete 166 days in space on board the International Space Station, scheduled to come back on Sunday, November 10th. Upon their return, they'll be bringing the Olympic torch back down with them, and completing about 6 months in space. So meanwhile on board, continuing to get some live video downlink of that capillary flow experiment. NASA astronaut Mike Hopkins working on that throughout much of the rest of the morning today. Some of the other research being done across the station involves another physics experiment known as BCAT. This one was being conducted by European astronaut Luca Parmitano. He was setting up some samples for that. The one he was working on, an experiment study looking at nanoscale particles dispersed in liquid. This state known as colloidal suspension. This is something that's commonly found in a lot of commodities commercially down here on Earth, such as paint and various food products. Once these particles are suspended, they'll have a very unique property that the particles will then self-assemble into crystals. One of the very unique aspects of operating in microgravity that has that crystal formation has a role in a lot of various biological experiments taking place on board as well. The crew members responsible for photographing these samples and allowing them to then be measured by scientists down here on the ground. This all hoping to give insight into the material process of these colloids. Also on board NASA astronaut Karen Nyberg working with a Japanese experiment over in Kibo today. That experiment, known as the resist tubule, looking at the mechanisms of gravity resistance in plants. Gravity resistance, one of the principal responses in plants, scientists believing played an important role in the transition of plants from only being found in an aquatic environment to a terrestrial environment, estimated to have happened sometime about 450 million years ago, resulting in the establishment of plants on land. The experiment study hoping to clarify the mechanisms of gravity response and resistance in plants, in particular the processes that they develop under signal transformation and transduction. Some of the results hoping to come out of that plant study, better understanding of the mechanisms of plants and their gravity resistance, hopefully enabling more efficient plant production, which would be an invaluable asset for humans living life for extended periods of time in space. Again, quite the gamut of experiments taking place on board the station, material sciences, various fluid physics, and also the plant study being conducted by Karen Nyberg. The Russian cosmonauts also taking their hand in a few experiments on the Russian side of the station. One of those, the Matryoshka study. The Russians have a mannequin-sized doll, if you will, with a number of dosimeters placed throughout it and various sliced portions. It's then placed inside the station, and all of those dosimeters constantly take data on radiation readings. Being a roughly sized to about the human body, the scientists and researchers are then able to estimate the actual dosages that these astronauts are exposed to radiation-wise during their long-duration space flights. Radiation, one of the major hazards in any spaceflight activity. Once you get outside of the Earth's protective atmosphere and magnetic sphere, exposure to radiation becomes a serious problem, especially on deep space flights that we're continuing to look forward to and strive for. So knowing just how much radiation these astronauts are exposed to and then developing effective ways to shield them from that, a very important step in safeguarding and ensuring any future mission success to these far-off destinations. The International Space Station serving as a platform, if you will, for discovering and learning to combat a lot of the negative effects of weightlessness. That radiation study, just one of those. All the astronauts constantly involved in a number of biological experiments with their own bodies acting as the guinea pigs, studying anything from bone loss to muscle atrophy, and also various organ responses to extended stays in microgravity.
It was very difficult to keep the bubbles apart once I shook the apparatus or the chamber and broke it up, and as soon as I would let it go, they would tend to join back together. So when I got this one, but it doesn't look like it's going to want to really go anywhere. I thought I'd take a look, let you guys take a look at this first.
Mike, we copy. Please stand by for just a second as we discuss. Station CFE Portland on 3 for Mike. Do you feel like more liquid inside the container would help?
Yeah, I'm not sure that could help. I guess press it down a little more and make the bubbles smaller. And then I guess does one of the bubbles need to be at the step in order to get this thing to move?
Mike, that is correct. Yes, the bubble needs to straddle the step in order for movement to occur.
Okay, why don't you give me one more shot at it, and if that doesn't seem to work, then we can try putting more fluid in the chamber.
We copy.
So continuing to get some live views of that capillary flow experiment. NASA astronaut Mike Hopkins continues to work. You're hearing him speak with one of the principal investigators at the Portland State University in Portland, Oregon. A number of the experiments on board the International Space Station supported and operated and initiated by various universities around the country and also around the globe. The NASA infrastructure allowing them to converse directly with the astronauts during their experiment runs, as they're the experts giving the astronauts any direction throughout. And today that capillary flow experiment taking place. Meanwhile, the Orbit 2 team here in Mission Control continuing to monitor and fly the International Space Station. That team again today being led by Flight Director Mike Lammers. You can see him on there on the right. Joining him at the CAPCOM position, our communication link between the ground and the astronauts, is Jeremy Hansen, an astronaut with the Canadian Space Agency. The teams here in Mission Control successfully overseeing the departure of that Cygnus vehicle earlier this morning. Again, the major task completed earlier this morning, the release of the Orbital Sciences Cygnus cargo craft, unberthed from Harmony at 5:05 a.m. Central Time and released from the station's robotic arm at 6:31 a.m. as flight engineers Luca Parmitano and Karen Nyberg were at the robotic arm controls. That release coming as the station flew just about 262 statute miles over the southern Atlantic, just to the east of Argentina. The cargo craft, originally carrying about 1,300 pounds of cargo to the International Space Station crew, now being loaded with trash and released for an eventual destructive entry through the Earth's atmosphere. Flight to the International Space Station going flawlessly, and the unberthing and release going flawlessly as well this morning. Orbital flight controllers will have one more major task with the Cygnus vehicle as they prepare for its final deorbit engine firing tomorrow at 12:41 p.m. Central Time on Wednesday. This will allow the craft to again make that final descent through the Earth's atmosphere and burning up upon re-entry. Orbital Sciences completing their final milestones under the Commercial Orbital Transportation Services contract. Will officially come online as the second U.S. commercial resupplier to the International Space Station, joining SpaceX in their Dragon capsule. Again, that's some video from earlier this morning. The Cygnus vehicle successfully deberthing and departing the International Space Station. All those major times you one last time. Unberthed from Harmony at 5:05 a.m. Central Time. Released from the Canadarm2 at 6:31 a.m. Central Time. Thrusters firing 2 minutes later at 6:33. And that final deorbit engine firing taking place tomorrow afternoon on Wednesday at 12:41 p.m. Central. So meanwhile, on board the International Space Station, pretty exciting. The EarthCam firing up for another mission this week. Kicking off today, October 22nd, and continuing throughout the week until October 25th. EarthCam, the Earth knowledge acquired by middle school students, also known as the Sally Ride EarthCam. Originally initiated by Dr. Sally Ride, America's first woman in space back in 1995, was originally known as KidSat. We renamed the program to the Sally Ride EarthCam earlier this year in 2013. It allows middle school students from around the world to request images of specific locations of the Earth, actively controlling camera on board the International Space Station. If you want to learn more about it or sign up your class and get involved, you can go onto the website at www.earthcam.ucsd.edu. Again, doing about 4 missions every single year. This week's mission just kicking off today. So you can go ahead and check out that website if you would like to sign up and get your class involved. Really a very once-in-a-lifetime experience for a lot of students, a very exciting experience as well.
And shall I continue down to 7.5 now?
Yes, please. Yes, please. Thank you.
And CFE Portland Station on 3, heading to the lab cam.
We copy. We have you up.
So right now on board the International Space Station, the Expedition 37 crew moving into the late afternoon portion of their day. NASA astronaut Mike Hopkins continuing to work with that capillary flow experiment. His fellow NASA astronaut Karen Nyberg is doing some final Cygnus wrap-up, stowing the craft's hardware control panel after she's already completed breaking down the robotic workstation in both the station's Destiny laboratory and also inside the cupola. Both astronauts will have some exercise scheduled for the end of their day. Every single astronaut on board getting in about 2.5 hours of physical activity on board every single day in order to combat a lot of the negative effects of weightlessness.
The focus plane of the camera is a little bit closer than you are, so could you come a little closer?
Mike Hopkins continuing to speak with the principal investigator of that capillary flow experiment. You can see him with the experiment held up here.
Yes, there's just not enough time. Yeah, we can see that. That's great. That's great.
So I think it.
Meanwhile, the Russian cosmonauts on board Continuing with a few maintenance activities, Fyodor Yurchikhin right now over in the Zarya module doing some fan screen cleaning. His fellow Russian cosmonaut Oleg Kotov right now working with that moto cart experiment on one of the station's treadmills, looking at locomotion responses for these astronauts. We're also moving towards the end of today's Space Station Live, so I have a few quick programming notes for you. Coming up tomorrow, we'll have a PAO event where Karen Nyberg will be speaking with students at the Henning School District in Henning, Minnesota. That'll take place, again, tomorrow, October 23rd, here on NASA TV at 9:45 a.m. Central Time, 10:45 a.m. Eastern Time. Also, immediately following today's broadcast, we'll have the NASA video file where we will be able to show you the crew news conference of those next 3 astronauts and cosmonauts of the crew of Expedition 3839 that was held earlier today in Star City, Russia. Again, that taking place immediately following today's SSL at 11 a.m. Central Time, 12 p.m. Eastern. That will pretty much wrap it up for us today. Be sure to join again tomorrow for more life on board the International Space Station. This is Mission Control Houston.